Now, I want to talk about the different types of data that we can have, right? Data sources, sample population, sampling methods, all that stuff. That's what we're going to cover in this chapter. So, really, the first thing we want to talk about is the different types of variables and data that we can have, right? So, the one thing we always start out with, right, is an observation. It's just the single measure of what we want to find, right? It's the question that we ask, okay? It could be the thing we want to study, right? So a person, a firm, college, church, business, whatever it is, that's what we're studying, okay? A variable, I know we all know what a variable is. We've used them 100 times in math, right? It's just, it can be a number, and we don't really know what it is yet. Usually it's defined by X or a Greek letter or whatever, right? It's just a characteristic of the subject or individual. So it could be something we're trying to study, something we're trying to find. It could be anything, right? So like a variable could be a person's income or an invoice number, invoice amount, stuff like that. That's a variable. Last thing, I hope it's pretty self-explanatory, but a data set is if I just have a bunch of numbers, right? A data set would be all of those numbers together. Usually they have something, they don't really necessarily have to have something in common, but a lot of times it's just the big pool of everything that we find, we put in a data set, okay? We'll be more specific in a little bit, but mainly that's just really what we want. We find data, that's our data set, okay? And it can have a lot of different variables in that data set, okay? It doesn't have to be just one singular thing. It can be like a person's name, their income, their job title, their company they work for, stuff like that. That's a data set, okay? And that goes with univariate data sets. And like I said, univariate means one, right? One. That's a one variable data set. Bivariate data set, two. And I think after that it just goes to multi because they were tired of making up numbers or making up names. So it's a multivariate data set, more than two, okay? And so how do we, what are we doing with them, right? It can have mainly two different types of data sets, two different data types, and that's categorical data and numerical data, okay? Categorical data, pretty self-explanatory, right? What's my name? Excuse the handwriting, okay? My name is categorical data, okay? There's no numbers involved with that. There's nothing involved with it besides letters. That's categorical, okay? I'm not much older than you, but 24. That's how old I am, okay? Welcome to my life, right? That's numerical data, right? Numbers, really simple, okay? And we can have different types of categorical data as well. I guess I should move this over here. Let's move this. 24, okay? So we can have two different types of categorical data, right? We can have the verbal label, which is kind of what this is. This is a verbal label, right? Or we can have what's called a coded categorical data. And it can get a little confusing, but watch this, right? So if I ask a person in a survey what their gender was, okay? I can say enter 1 for male, and enter 2 for female, right? It's categorical data, okay, because we're asking them to identify male, female, right? But it's coded with these numbers, right? Don't get that confused for numerical data, okay? It's categorical, right? It's just coded, okay? So that's the different kind of data that we can have, right? It's pretty easy to differentiate between the two, right? This one, there's no number associated with it. This one there is, okay? The two different types of numerical data that we can have, discrete and continuous. And so in this case, discrete, it would be my age. I wouldn't really say my age more or less, but categorical could be really just all the integers, right? And the integers are just, if you're not familiar with integers, it's just 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to whatever number, right? They're whole numbers, okay? That's what integers are. So as long as it's a whole number, it's discrete, okay? And continuous, right? I'm not going to tell you a continuous number, but a lot of times it deals with like weight. If you're weighing something, right, you can have something that's, 150.56789 and on and on and on, right? Because we never can get the most, we can never get it, right? So that's what's called a continuous numerical data, right? Because we can never get this to the exact number that it is, okay? Same with distance, right? We can go 1.678259 miles, but we can never get down to the precise measurement of distance, okay? But we can always, like I said, we can always cut it off here, right? And it can look like it's discrete, but like, hey, this is, 150.56 pounds, but that there's probably more numbers added onto that. It's still gonna be continuous. Don't let it fool you, it's not discrete, okay? But if I was to ask you, let's say, hold on. Yeah, so normally you can kind of identify discrete numbers with, in the survey it starts with number of. So if you say number of students in the class, right? 7 of you, 8 of you, okay? That's discrete, really easy to remember, okay? If it says number of, fill in the blank, you can bet it's probably gonna be a discrete discrete numerical data. Right, if like I said, weight, time is another one, yeah, that's another good one. Usain Bolt, one of the fastest humans in the world, ran a 100-meter dash, 9.58 seconds, something like that. I don't really know. You can, don't check my math, but it wasn't 9.58, it was probably 9.58 blank, 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 something, but they were gonna round it up to the 100th decimal. So really easy, but people can it can kind of go back and forth and people can get confused on it. So, it's really important to kind of differentiate between these two. So this is where we pause the video. Way to go. You made it through another section, but we're going to do some examples, some problems for you guys. Team up, talk about them. This is really just differentiating between categorical data, numerical data, and the 4 different types we have, okay? So get with a partner, talk to them, and then we'll discuss as a class, okay? So pause the video, and we'll get back. Okay, so we're back. I hope you guys were able to figure out the problems, talk about them, discuss them. But moving on, so we talked about types of data, the different, categorical, numerical, all that stuff. So now we're going to talk about the different kind of concepts of sampling. Okay, how do we sample? Different ways that we can sample, stuff like that. So first things first, I want to talk about the difference between a sample and a population, right? Because you can sample both, right? You can sample a sample and you can sample a population, but let's differentiate when we should be doing that, okay? So obviously a population, right? The population of the US is a lot. I don't really know. I think it's like 320 million people, something like that. It's a lot of people, okay? If we were to survey 320 million people, you know how long that would take? That's my point, okay? We could take a sample of the population, right, where it's we can sample the people in just the state of Arkansas, which is still close to 3 million, something like that. It's a lot of people still, but it'd be a lot more manageable than 320, okay? So the population is just the thing, the amount of the group of people that we're interested in. So all of the people that we're interested in, right? But the sample is the subset of that population, okay? And a lot of times we'll take a subset of that sample if the population is like an infinite population. So let's say like a manufacturer of a Tyson plant, right? They do a lot of chicken, a lot of stuff. I used to work actually for a conveyor technology. They did a lot of things with the conveyor belts that ran those the plants and did all that stuff. So I'm familiar with a little bit of their work. But for instance, like if I was to try and take a sample of the population of, I don't know, the amount of chicken that goes through the plants each, or I guess not even for a specific time period, but just as overall, I couldn't calculate that number because they're constantly running the plant, constantly manufacturing more of the Tyson chicken that we eat, right? So there's no way to actually get an accurate number of that population. But I could take a sample of that and say, what's the number that they produce in a month, right? I can. It'd still be a big number, but I could actually put that into, there'd actually be a cap on that. Okay, so that's the difference, right? That's when we probably want to use a sample between a population, right? But like I said, don't make conclusions from a really small sample because we never want to do that. All right. But we could take we could sample up a population. If it was a small population, like I don't know the smallest town in the state of Arkansas, but there's probably a town out there with 180, 200 people in it. You could easily take a sample of that population. Okay, that's the whole population. We can take a sample of it because it's really not a huge feat to do, right? But if it's 1 million people, that's a hefty ask. Okay, so just kind of making your best judgment onto when to use when to sample the population, when to sample or when to just do a subset of that. Okay, sorry, I forgot to erase this from last time. Okay, all right, guys. So what we're going to talk about now is what parameters are. Okay, so what a parameter is it's just the variable or the characteristic that you're measuring within the population. Okay, so there's a difference between parameter and there's a difference between statistic. They're not the same thing. They're different. Okay, so parameter all right, let's say we're going to talk about usually it's the parameters what we're trying to find within the population, right? So it could be any variable, usually like a mean, aka average, or standard deviation, which we'll talk about later, median, all that stuff. So it's just whatever we're trying to find within the population, okay? And usually these are denoted by like Greek letters. So in this case, a lot of times it's denoted by this symbol here. This is just a Greek letter. I don't really know, I can't remember which Greek letter. I want to say mu, but don't quote me. Okay, so this is the mean of the population is blah, 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 blah. Okay, that's what the parameter is, right? And we can also have standard deviation, which would be, usually it's denoted by this. Standard deviation is that. Some call it variance as well. I normally just call it standard deviation. We'll talk more about that in a later chapter, okay? But that's what a parameter is. It's just a measurement of the population, right? And so the difference between parameter and statistic is the same thing, except it deals with the sample, okay? So parameter parameter deals with the population, okay? Parameter, population, assimilation. There you go, okay? Real easy to remember, right? So a statistic deals with the sample. Again, they make it easy for us. Parameter, population, P for P, and then S for S, okay? So statistic right? What? Did I do something wrong?
No, I thought it was spelled wrong. I'll just cut that part.
Oh, okay. So, statistic. Ah, God.
I'm so sorry. Keep going. You're doing great. I'll just cut this part.
Okay. So, statistic, right? It deals with the sample, all right? And it makes it easy. Parameter, population, P for P, statistic, sample, S for S, okay? So, sample. All right. And normally what we do is we don't want to use the same Greek letter for statistic, right? We want to differentiate between the two. Again, that deals with communication with numbers. It deals with accuracy, all that stuff. It just helps kind of differentiate and makes it easier to understand which one's from which sample and which one's from which population. Okay, so normally they denote the mean of a sample with X bar. Not really creative, but it helps with differentiating. Okay, so this is the mean for the statistic, or the average for the statistic. All right, and you can denote the standard deviation really however you want. Not really however you want, but it has to be different than this symbol here. So normally what I do, since this is X bar, I'm just going to put this as Y bar. Okay, and this just helps differentiate it. Again, like I said. It helps us understand which one's from the statistic, which one's from the parameter, and helps us differentiate between the two. Okay? So what we're going to do now is we're going to pause the video and we're going to do some questions. This one deals with, it just kind of asks some questions. Would we like to actually take a sample, or would we like to just take the whole population and survey the whole population? Okay, so another word for it is census, right? Do we take a sample or do we take a census? So I want you guys to talk about this as a class. Mrs. Bernardi will lead the discussion, and we'll see you back after y'all talk about it. All right, we're back. Cool. This time, let's talk about, we're going to get into some sampling methods. This is just ways to pick which people you're going to survey or which people you're going to obtain data from. So we have some random sampling methods that we could talk about. Like I said, just a simple random sample. Simple random sample means I'm just going to pick people at random, right? If I have a list of people, I'm just going to pick, I don't know, you could do it a number of ways. Just pick random people on the list, right? Or I could, ask one of you to raise your hand. Or not even raise your hand, I could just pick on one of you. That's a random sample, okay? I would do that, obviously, because I'm here and you're there. But you get my point. I'll have Miss Bernardi do it. And like I said, there's also ways, like calculators, especially calculators nowadays. Most TI calculators now have a function where you can have them generate a random number. Excel has a function where you can generate a random number. Google Sheets, I'm pretty sure, has the exact same function. So if you're not sure how to randomize a sample, Excel can do it for you. So work smarter, not harder. And in a random sample, you can either sample without replacement, you can sample with replacement, and those are pretty self-explanatory. Without replacement means if you use it, you can't. If you use it, you lose it, right? Can't replace. You can't put that person back in the pool of people to be picked out. Okay. Sampling with replacement is kind of like the function like the calculators do, the Excel, that stuff. They will do sampling with replacement, right? They can use the same number over and over again in a random sample. Okay. So just be wary of that. If you know, like, hey, I want to sample this person, or sample this data set, or this subset of people, you have to differentiate between whether you want multiple answers from, or multiple sets of data from the same person, or you want to survey without replacement, right? I know sampling without replacement is a really popular one. A lot of people don't want the same number coming up over and over again. So that's definitely important, but you get my point. There is a systematic sample. Systematic just means I'm going to sample every 5th person, every 10th person, every 15th person, so on and so forth, right? It's just systematic, okay? You follow a pattern. And there's different ways you can do that too. It doesn't have to be just every 5th person, right? You can do something like that. So another sample that we can take is what's called a stratified sample. Again, this is another non-random sample. that we can take, but on page 38, I believe, that's where this sample comes into play in the book. However, it's not clear and I don't like it. So the way I'm going to teach it makes a little bit more sense. It's a little bit easier to understand. So just bear with me and we'll talk about it. So what a stratified sample is, let's say we want to take a survey of small towns in Arkansas, right? Because there's a lot of them. All right, so let's say we have a small town of 200 people, 400 people, 600 people, and 800 people. All right, relatively small towns, okay? But we want to figure out a way to take a sample of each of those and still make it statistically relevant, okay? Because a lot of times, 200 is definitely a lot less than 800. So how do we make that kind of evenly represented within our population? So what we're going to do is stratified sample. I can set a sampling ratio of 1/2, right? So our equals 1/2. All right, so what we'll do is we'll cut all these in half, okay? So we have, this one becomes 100, this becomes 200, this becomes 300, and this becomes 400, all right? That's really all this is, right? It narrows down our population, allows us to take a sample, but it's all proportional, right? Because all these end up being 1/2, okay, of the original population that we want, or original population that we have, and now it becomes proportional. So now every single population in our sample, or every single sample in our population is proportional to each other, okay? That's really all of what a stratified sample is. Real simple, real easy. It also helps with like lowering your error, so that way you can kind of get better results. So that's what a stratified sample is. Another sample type is a cluster sample, right? Just picking groups of people at random, like usually from like geographical regions. So like I'm gonna pick a group of people from this area, I'm gonna pick a group of people from this area, this area, this area, and then we're gonna survey them, okay? So just making it kind of a cluster of people in the same area, but they're in different regions, so it kind of nullifies that in terms of, and it kind of makes it a little bit more random. But like I said, this is kind of really inefficient, and it would cost a lot. The cost of doing it, especially with distance and all that, it's just not really that efficient. So it's not used a whole lot, but it is done some. There are some non-random sampling methods that are okay. I know I said don't make conclusions of non-random surveys, but there are ways to survey people non-randomly, okay? And it still be okay. First one is a judgment sample. Using an expert, they can kind of make a judgment on, hey, I want to survey these people based on this knowledge of, this company, stuff like that. So using that expert knowledge, again, though, keep in mind there's a pitfall there that can happen. I hope you guys know. If you know what it is, you can scream it out, but I'm going to tell you anyway. Probably unconscious bias. There can be a lot of bias in that judgment, okay? So it's just something to be worried about. Another one is convenience, right? Convenience, if I wanted to take a survey right here, right now, I could ask all of you a question. You all have to give me an answer. That's convenience, right? It's the most readily available to me, okay? Is it the most efficient? No, but I have an answer right now that I can use, okay? That's probably one of those ones where you don't want to draw conclusions from small sample sizes. Pitfalls can come into play. Like I said, I'm just kind of, running through this right now, but, it's just different things to think about, right? If you need an answer right now, this is probably the best way to do it. Convenience, okay? Another one is focus groups, right? I know a lot of people, we use focus groups in our business to test, like pilot things out. So, we're trying to lighten our workload because we're so far behind right now. Don't tell them I said that, but we're behind, we're busy, okay? So we have focus groups that we kind of test with these pilot features out for software. They can kind of help make processes faster. Hey, there you go. Always tying it back in and relating it. So, just helps make processes faster, makes our workload lighter. But these focus groups, they really are a small kind of group. It's like a 5 to 10 people selected. Usually they're very it's a heavy screening process. To kind of pick the people they know that they need. It kind of helps weed out what they don't want, and really helps the focus group kind of, it narrows the focus. So that's another way of non-random sampling, okay? But again, there's bias in that. There's all different kinds of pitfalls you can fall into, so you have to be wary of that when doing a focus group. But they are efficient if you know what you're needing and you know what to kind of look for. So like I said, guys, this is all in the book. I encourage you to read it. If you have it, I would encourage you to read along with me. But all this is in the book, guys. So please feel free to read it. It goes into more detail than I'm going into. This is just kind of a quick summary so you guys can have some background knowledge before we really get down to the nitty gritty. We're going to get into like different sources of error. So like I said, with all these different sample sizes, we can run into a lot of errors, right? Whether it be non-response bias. If someone says, I just don't want to answer your question, that's non-response. We can't use that data. It's really hard for us. That's an error, okay? Selection bias. That goes with judgment sample, right? I could select the wrong person to interview, to survey, to get data from, and it could throw off all of the analysis. Okay, response error. If someone gives me just an absolute absurd answer, I can't use that. Okay, measurement error. I could analyze it wrong, and I could put the wrong measurement. Again, that goes with imperfect data. I never want to give someone 90% of a photo. I need to make sure that my measurements are right, okay? But there is, like I said, no one's perfect 100% of the time, so we just want to do our best. So, but measurement, there can have some error in there, okay? The big one is sampling error, okay? Sampling error, it happens more times than probably any other bias or any other error, but a lot of times we tend to think that our sample size is good or the way we pick people is good, but we can mess that up more times than we probably get it right. So we want to make sure, extra sure, that our sampling is on point, okay? Okay. Next thing I just really wanted to quickly hit, data sources. A lot of people probably ask like, well, I don't even know where to get this data. Where do you find it? Well, where do you go when you don't know something, right? What's the first thing you do? You get on a computer and you go to Google, you go to Yahoo, go to Bing, any search engine. You can type something in and it'll pull up 100 different pages on what you're looking for, right? That's a data source, okay? Where we go to find the data we're looking for, that's a data source, okay? Really easy. But now we have smartphones that do it for us, okay? So it's just a different way to use it, okay? Real quick, I just want to hit surveys. The way we collect data is by surveying people, right? And so it's really an important aspect to data collection, data analysis, all that stuff. And so really what we want to do is we want to make sure that our surveys are the best that they can possibly be, so that way we can get the most accurate data, all right? And so there's really 5 different main types of surveys. We can have a mail survey, M-A-I-L, not M-A-L-E. I guess you could have a mail surveyor, but I don't know. M-A-I-L survey that comes in the mail. You can do it over the telephone. I doubt you'd ever talk to me over the phone, but you can do it that way. You can just do face-to-face interviews. You can do it over the web, and then there's direct observation. Okay, you don't really have to survey them. You just observe them and kind figure it out that way. Or I guess it can be done in a controlled setting is what I really mean. Some would classify that stalking if you didn't do it in a controlled setting, I'm sure. So don't do that. Questionnaire design, we always want to design our questions and fit the design of the survey to how we want to steer our data, okay? That's a really big, important part of surveying. We want to make sure that we're asking the right questions the right way, wording it the way we want it to, because a lot of times people can get confused if we word it weird, and it throws off all the data. So we want to make sure we're precise, efficient, and word it correctly. You guys can kind of go through that in this book. I'm not going to hit that, but that's the end of chapter 2.